So this is Aisha Khalid. I'm working in Ministry of Works as a database administration, head of database administration group. And today I'm going to present this paper entitled Machine Learning Approaches to Mitigate the Transportation Traffic Congestion. And this paper is a part of my master thesis conducted in University of Bahrain, and with the master program Big Data Science and Analysis. This program was validated by Liverpool John Mercy University. I'm graduated from the program, alhamdulillah. It was supervised by Dr. Wael Al-Madani and Dr. Professor Nabil Houehi. So as a roadmap for this presentation, we'll start with the introduction, followed by the methodology, then jump to the result, then the conclusion, and finally, the discussion, then finally the conclusion, which includes the recommendation and future work. So, and the introduction, who's not suffering from traffic congestion these days? So the traffic congestion actually one of the most problems that occurs in ITS, which is the Intelligence Transportation Systems. Most of the research are conducted in this field, the traffic congestion. Oh, sorry. So how to solve this kind of problems? The traffic engineers or the transportation engineers are monitoring and collecting massive of data in order to understand the problem of the congestion to put the solution for it. So this poses multiple challenges due to the scalability and massive data that it generates. And talking about our beloved Bahrain, it's ranked as the 11th globally in traffic congestion and the 4th in Arab countries after UAE, Kuwait, and Jordan. So this paper or research objective is to find a solution for a junction that suffer from traffic congestion using machine learning techniques in Kingdom of Bahrain. So this research is an exploratory design research using machine learning approaches. It covers all the junctions in Bahrain. These junctions are 56 junction that has 4 type of traffic controls: unsignalized, signalized, roundabout, and grade separated. This data has been collected from Ministry of Works reports. 6 of them are project-based reports, and 2 of them were annual reports. These reports are covered the period from January 2014 until November 20. So the methodology, starting with the methodology, the database, after being collected, it shows that it's been highly unbalanced, unfortunately, as you can see in the figure. So to overcome this problem, we applied oversampling methods. These methods are smoothie, adaptive, the synthetic, and random oversampling method. And the fourth one is merging all the data set extracted from these oversampling method, and we call it the hybrid. So the machine learning approaches that used in this research are SVM, support vector machine, KNN, decision tree, random forest, and multilinear perceptron. With these parameters, and for evaluation criteria, we used accuracy, recall, precision, and F measures. For summarizing the methodology, this research started with extracting the data, then attribute selection, then data cleaning. After we clean the data, we have the original data. Then we had also data oversampling with the 3 methods that I mentioned. Then we have the hybrid. From each of these, we have separated data sets. We put it in the stage of model building using the 5 machine learning approaches, and we end up with 25 models that evaluated with the evaluation criteria mentioned earlier. So the results are going to be presented based on scenarios. The first scenario is when the data is unbalanced. The second scenario, after applying the oversampling methods. The first one, smoothie. Second one, adaptive synthetic. And the third one is random oversampling. The third scenario is using the hybrid data set. So as you can see, this is the first scenario. The instances are too few, unbalanced, only 259 instances. You can see the precision and the F measure showing a non-available result because the Weka that used for this research cannot identify any corrected prediction results. So the highest were in the random forest, the lowest were in SVM. For the second scenario, using a smoothie as an oversampling method, you can see here clearly the data is unbalanced, 20% for each class, 196 instances for each class, and the total instances were 980. The best accuracy were with KNN, 96, and you can see the jump in accuracy, and the least were in SPM. For the same scenario, second oversampling method, the number of instances even increased, 997 instances. The classes were balanced. The range of instances in each class, 196 to 202. The best machine learning approach were KNN with 97, and the least were in SVM, 79. The last oversampling methods in this scenario was random oversampling. It has also, you can see, 20% for each slice, 196 for each instance, for each class, total instances 980. The best were in SVM with 100 accuracy, and the least were with MLP, multi-layer perceptron, 89. The last scenario, which is the hybrid, you can see the number of instances has been increased to 2,957. It is balanced with 20 for each slice. The instances in each class were ranging from 588 to 594. The best were with KNN, the best accuracy with KNN 100%, and the least were with MLP 91%. As a summary of a result, you can see that generally all of the machine learning methods perform better after applying the oversampling methods, especially the hybrid that shows a higher accuracy. KNN and random forest perform better better than the rest of the machine learning approaches. SVM was the best in random when used random oversampling, and SVM and multi-layer perceptron perform lower than the rest in general. So as a discussion, overall, KNN and random forest were the best mostly when applying it on all data sets, especially when using the hybrid of all oversampling methods. You can see that this paper or this research proves that there is a pattern in finding the solution of the junction using machine learning approaches that capture and learn from that. Unlike the previous studies, the common machine learning approaches that they use were CNN and LSTM, long short-term memory, which does not suit the nature of the data that has been collected from the reports. They usually used spatial temporal data. So as a conclusion, the machine learning power, it shows the possibility to predict the solution of traffic congestion problem with an accuracy that reach 100. Oversampling shows how it shows the way of maximizing the accuracy and performance. The hybrid method showed better results. And of course, by applying this, it will support the decision making. Recommendation and future work, to use ML, machine learning prediction in the construction site to mitigate the traffic congestion. Because usually, in other researches, there is a rich research and traffic congestion, but they are not tackling finding the solution from construction side. Centralized database using tools for database representation and manipulation of the data collected. Use wider range of data to add more attribute in the data to have more accurate decisions, and try other different oversampling method and machine learning. Thank you for listening.